Hi, my name is Ashika Dhuria, and this is my Physics 2211 Lab 1 report on constant velocity. In this presentation, I'll go through the following topics: an introduction with important concepts and diagrams, an analysis of the motion of the line, a construction of the computational model, an observed versus predicted graph, and I'll end the presentation with some follow-up questions. This lab demonstrates Newton's first and second laws. Newton's first law states that an object will not change its motion unless a force acts on it. Hence, an object in motion will stay in motion, and an object at rest will stay at rest, unless an external force acts on it. And Newton's second law states that the force on an object is equal to its mass times its acceleration. In this case, because we're assuming that no external forces are applied, such as air resistance and friction, other than the initial applied force, the object will travel at a constant speed and velocity according to Newton's first and second laws of motion. The final velocity formula numerically represents the concept of movement at a constant velocity due to an equilibrium in net force. Using this information, the final position formula numerically represents the position the object will be at after a change in time. For this lab, I rolled a line across the countertop and assumed that air resistance and friction are not acting on the line. Hence, there's no net force acting on the object through the motion of the object. To initiate movement onto the line, I applied a small force in the negative x direction, making the line travel further in the negative x direction at a constant speed and velocity. The line is moving with a constant velocity as the normal force and the gravitational force of the line will cancel each other out. This is shown on the diagram to the right. To visually examine this concept, I used the tracker program. To track the position of the line during the time interval, I placed the x-axis along the horizontal path which the line was moving along and placed markers in the center of the line throughout the duration of the movement. The position time graph of the movement of the line is shown in the top right of the visual on the slide. I then constructed a computational model of the theoretical movement of the line through GlowScript. In the code, I incorporated the final velocity and position formulas previously mentioned in a while loop. For the initial position in the code, I used the position found at 0 seconds in Tracker. I then found the average velocity through the time interval also given by Tracker and was able to plug both of those values into the starter code which was given to us in the lab assignment. From there, I kept the mass of the object at 1 because I knew that it wouldn't really affect the computation of the formula. I also used 1/60 for delta t because I filmed the initial video of the line at 60 frames per second, and I thought that 1/60 would be a decent time step to use for the data. Lastly, I knew that I only wanted the while loop to iterate through until 1.034 seconds, aka the length of the video in Tracker. So that's what I used in my initiation for the while loop. This is my observed versus prediction graph, which displays the position time data corresponding to the computational model on the blue line and from Tracker on the red line. As you can see, the lines are very similar, but at the same time very different. They both follow a negative slope, but the observed data is clearly not as consistent as the predicted data, as seen through the slight variations in slope on the red line. This is most likely due to friction and air resistance in the model, as well as slight inconsistencies in timing and location of the markers in the Tracker model. Lastly, I'll discuss a few follow-up questions. What if the axes were flipped? If the positive x and negative x directions were flipped, the slope of the graph would be flipped, or multiplied by -1. Lastly, how many forces are added added together to give a net force of 0 in the case that we observed. To my knowledge, I believe that there are 4 total forces that are being added together to create this 0 net force: the normal force, the gravitational force, the applied force, and the frictional force. Thank you so much.